Okay, we have learned in last lecture about the trigonometric functions, and there are two basic trigonometric functions, which are the sine and cosine, and we have learned how to sketch these two functions. For example, we have known that what is the cosine and sine. We have known that there is another name for trigonometric functions, which is circular functions, which comes from the concept that circular functions, or cosine and sine, are just the x and y coordinates of a point moving on a unit circle. So that's why this is cosine theta and this is sine theta of this theta. So whenever you are on that circle, moving on that circle, the coordinates change, and so are the cosine and sine. Okay, so that's why we graphed sine and cosine. Let's remember, we graphed the function cosine theta with theta. It was as follows. When we moved with the point around the circle, we found that that was the graph of cosine theta, which starts from theta at theta equals 0. It starts with the value 1. That's why cosine 0 is equal to 1. What does that mean in that in the graph? It means that at an angle, which is an angle 0, where is the angle 0? An angle 0 is that angle 0. That is the angle 0. An angle is measured to the positive x-axis. An angle is always measured to the positive. When I measure this angle, it is measured. This is the starting side of the angle to the other side. So that's how an angle is measured. The positive with the positive x-axis. Okay, so for the angle 0, you'll have this represent the angle 0. More specifically, that point will represent the angle 0, which has the coordinates 1 and 0. 1 and 0 are just that is the cosine of 0, and that is just the sine of 0. That's why cosine starts with 1. Okay, and for sine theta, we have learned that it starts with 0, like this, and it has just a similar curve that is for sine theta, but you can consider it as if it is shifted. And we have learned that cosine theta is an even function. That's why cosine of negative of any expression is just the cosine of that expression. And we have learned that the sine is an odd function. That's why sine of negative of an expression is just the negative. The negative goes out the sign, so it will be negative sine of that expression. Okay, so that's the cosine theta and sine theta. And we have learned also that what is the period of the cosine theta and sine theta. What is meant by a period? A period is an interval for which the function repeats itself. It's an interval for which the function repeats itself. If you notice here that starting from here, then you will eventually get to 2 pi, which is 360 degrees. When you have a full rotation, then you will start over again. You will start all the journey all over again. So that's why starting from that 2 pi, you will just start again and repeat yourself. That's why we call that the period of that function is 2 pi. The period of that function is 2 pi, and so for sine theta. Okay. Now that 2 pi is divided to four intervals, which are the four main intervals, which are on the axes, which are on the main axes. Here we have pi over 2, which is that angle pi over 2. Then we will have pi, then we will have 3 pi over 2, then we will have 2 pi. So these are the four main angles, which I should know the sine and cosine of them without using any calculator. Why? Because when I tell you find sine 3 pi over 2, that is a known angle. This is that angle. That is 3 pi over 2. This is that angle. And I know these coordinates. What are the coordinates of these points? They are 0 and -1. So that's why the cosine of that angle, cosine of 3 pi over 2 is just 0. And the sine of that angle is just -1. Okay? So by the unit circle we can know the sine and cosine of the 4 main angles without calculators. Without calculators. Okay. Today let's learn some properties or some characteristics of the sine and cosine functions when we change the argument of that cosine and that sine. When we change the argument of that sine or when you change the theta. For example, if we had f of x in that expression, f of x is equal to a sine or cosine omega x plus b. So that is a general expression for what we call a sinusoidal function. Sinusoidal function, which is a function which is sine or cosine. We call a function which is a sine which looks like this, we call it a sinusoidal function. A sinusoidal function, a cosine which can be expressed as a sine of omega x plus b or a cosine. Sine and cosine are all in a same category, which we call them sinusoidal functions. Okay? So that is a general expression for a sinusoidal function. We will give some terminology for the parameters we have for this function. For example, that is called the amplitude. That is called the amplitude of the function. What is the amplitude? Amplitude, no, this is not exactly the amplitude, but the absolute of that number is just the amplitude. Okay? The amplitude is equal to absolute of A. Amplitude is equal to absolute of A, which we take the value of that. If it was negative, no, we don't say that the amplitude is a negative value. It is never a negative value. This we call this the angular. This is called the angular frequency, or sometimes angular velocity. Okay, which is the coefficient of x. The coefficient of x is called the angular velocity. What is omega in general? Omega, whenever you study an omega, it will be expressed like this: 2 pi f. Whenever you have an omega, even if you studied in physics, if you studied it in dynamics or mechanics and so on, you will find that omega is always 2 pi f. So that is a memorized expression. Okay, omega is 2 pi f. What is f? F is the frequency. F is the frequency. Okay, so whenever you repeat something, there is a frequency for that repetition. For example, if you have these two curves, which of these has a greater frequency? 1 or 2? Which has a greater frequency? What do you think? Yes, 1 has a greater frequency. It repeats itself more quickly. So we have a much more frequency in this one. So what is a frequency? A frequency, it is the rate at which you repeat yourself. If it is fast, you repeat yourself fast, then we have a higher value of the frequency. Okay? If you have, for example, this, you repeat yourself slowly. So we have a lower value for the frequency in this case. Okay? So that is the frequency. So we learned that the frequency is just the reciprocal of the period. This is just the reciprocal of the period. So whenever you have a greater period, you will have a less frequency. This is just the case. It is obvious in these two examples. For case 2, what is the period in this case? The period is this interval. What is the period in this case? It is just this interval. So whenever you have a small period, you will have a greater frequency. And oppositely proportional, it will be it will be opposite proportion to the period. So whenever you have a greater period, you will have a less frequency, and so on. Okay. That by itself is called the frequency. If you multiply it by 2 pi, then it is called angular frequency. Why? Because you just measure it by an angle instead of a cycle. In this, the mean definition of a frequency is how many cycles do you make in a second. How many cycles? That is the rate of your repetition. How many cycles do you do in a second, for example? That is a frequency. Okay. When you make it, what angle do you do in a second? That is when you multiply it by an angle. So a total cycle is represented by an angle 2 pi. A total cycle is represented by an angle 2 pi. So if you want to measure how many cycles, or what is the angle did you what is the angle that did you achieve in a given time, that will be, you will just multiply it by 2 pi, because one cycle is represented as an angle by 2 pi. One cycle is represented an angle by 2 pi. Okay. So that's why this is called 2 pi f. So whenever I give you an expression, a sinusoidal expression, you are required to compute the amplitude of that sinusoidal expression. Also, you are required to calculate the angular frequency. You are required to calculate the frequency itself. Frequency, we just ask for the frequency, not the angular frequency. We get the frequency from the angular frequency. Okay, and you are also required to compute the period. You are also required to compute the period. What about that B? What about that B? That B is called the phase shift. Phase shift. Phase shift is just a shift in the angle. What is a phase? A phase is just an angle. A phase is just an angle. So that's why we call this as a whole, we call it a phase. We call this as a phase. Why? Because omega times x is just a phase, or just an angle. Okay? That is an angular frequency multiplied by x, which in general it is represented by time. So you multiply an angular frequency by a time, you will get an angle. Eventually you'll get an angle. Okay, so that is an angle. In this case, when we say there is an angle inside the sine, we call it, in many times we call it a phase. We call the angle a phase. Okay, so if you add b, you are saying that you are making a phase shift. You are making a phase shift. But we will not focus or pay much attention on that phase. We'll just put our consideration on the amplitude and the frequency and the period. Okay, so these are the three parameters, or the three characteristics that we will study in more detail, or we'll just consider it as more important. Okay, just a note, the amplitude is just the maximum minus the minimum, the difference between the maximum and minimum divided by 2. For example, if you had that graph, what is the amplitude of that graph? For example, you just take that difference, the difference between the maximum and the minimum, and you divide it by 2. So what is the amplitude in that case? The amplitude is just this. This is the amplitude. This is the amplitude. And in this case, for example, the amplitude was 1. In this case, the amplitude was 1. Okay? So let's check an example. If I had, for example, f of x is equal to 3 minus 2 cosine 3x. That constant doesn't make a change for our characteristic. Why? Because this is just a vertical shift. We have learned in the last lecture that if I have a function and add some constant to it, if I add some constant to it, that is just a vertical shift. You just take it upwards, for example, 3 steps. Okay, so that doesn't change the amplitude. That shift doesn't change the characteristics of the given function. It doesn't change the amplitude. It doesn't change the frequency, and so on. It's just a shift. You're just shifting it. The characteristics are preserved as they were. Okay. So, what is the amplitude? You need the amplitude for this function, and we need the frequency and the period. We need these 3 parameters. How to get these 3? Okay, what is the amplitude? We just take that number and in the absolute. So it will be 2. It will be 2. What about the frequency and the period? You just take the coefficient of x and call it omega. The coefficient of x, you call it omega. Okay? So omega is 3. What does that mean? We know that omega is just 2 pi f. So f will be 3 over 2 pi. So f will be 3 pi over 2 pi. 3 over 2 pi. 2 pi. What about the period? The period is this is the reciprocal of the frequency, which will be 1 over f. So that will be 2 pi over 3. 2 pi over 3. Okay, let's check the next example. If I had this function, f of x is equal to 2 sine pi x plus pi. Then sketch it. F of x is equal to 2 sine So try to find the amplitude and frequency. Okay, now with your pen, just try to find the amplitude and the frequency of this problem. You should have solved it by now. You are all in the WhatsApp group. Yes? Any of you is not in the WhatsApp group of group 6? Where is the admin of group 6? Here. Add them, okay? Okay, so I will solve it now and check with me your answers. Now, where is the amplitude? Yes, it is just 2. Amplitude will be absolute to 2, which is exactly 2. What about the frequency and the period? We get it from that pi. The phase shift doesn't make a change for me for the amplitude and frequency. The phase shift is just a horizontal shift. The phase shift is just a horizontal shift. So it doesn't change the characteristics of that function. The amplitude and the frequency, these are the characteristics of that sinusoidal function. Making a shift, even if it is horizontal or vertical doesn't change the characteristics of this function. Okay, so that is omega is equal to pi. That's why 2 pi f is equal to pi. So f will be equal to half. F will be equal to half. What does it mean that is f is equal to half? It means it makes half a cycle. It makes half a cycle in a unit time. Okay, it makes half a cycle in a unit time. So that is f. So what is the period? We call the period p or t. These are two known notations for a period. P, which comes from the word period, and sometimes t. That is a more used notation when we are dealing that the variables are time. When the variables are time, we call the period t. By the way, when the variable is space, sometimes we can have a wave. We can have a wave like this, but in space instead of time. What we are calling that was a change in time. What we have studied is a change in time. If the change in space, we just call the period, we call it the wavelength. Have you met that term before? Wavelength. That is just the period. That is just the period. But when you deal variables, when the changing variable is the space or not time. Okay. When you say time, we call it a period. We call it a period when the variable is time. But when the variable is space, we call it a wavelength. Okay. And it is commonly denoted as lambda. Okay. Let's return. So that P will be equal to 1 over f, which is exactly 2. So we have known the characteristics of that function. Now he's requiring a more. He's requiring me to sketch it also, to sketch that function. Now to sketch that function, you may need to. We know how to graph sine x. That is the basic function that we know how to graph or how to sketch. Okay? By the learned transformations, the transformation that you have learned in the last lecture, you should know how to eventually get to this, to get the sketch of this function. For example, this is multiplying a function by so that is a vertical scaling. For example, here when you pi times x, that is a horizontal scaling. That is a horizontal scaling. Adding pi to this is a horizontal shift, because you put x, every x you put it x plus or minus a function. But we'll just for sinusoidal functions, we will graph them by another way. We will use the characteristics that we have just calculated to graph our function. How? First, if you have a phase shift like this, just make a simplification. So 2 sine pi x plus pi. Can we make a simplification for this expression? Yes, we have learned, if I have this, in the last lecture, we have learned how to find theta plus pi. How to make a simplification like this. This is for addition of two angles. So we learned that had what is the rule that governs this simplification? Sine theta cosine pi plus cosine theta sine pi. If you can't remember, you just check the last lecture and you will find that there is 3 laws, one for cosine A plus B, another law for sine A plus B, another law for tan A plus B. These laws must be memorized and you know how to apply them. Okay? So whenever I have an angle like this, we can simplify it by these laws. Okay, so we'll have here, what is cosine pi? What is cosine pi? We just check it in the unit circle. The unit circle, a pi, this is the angle pi. So we'll have this point. This point is -1 and 0. What is the cosine of this angle? It will be minus 1, so that is minus 1, and the sine of that angle is just 0. So this function is just minus sine theta. So whenever I have sine an angle plus pi, this is just f of x. That same f of x is just minus 2 sine pi x. This is just the same function as above, and that is easier. That is easier in sketching. That is easier in sketching than this one. Why should I deal with shifts, horizontal shifts with at the same time some scaling in it? That will be somehow cumbersome, but this one is just easier. So how would you graph this function? We will graph first this function. Okay, now we have learned that the period of this function is just, what is the period of this function? It is 2. The period is 2. We just calculated it. We just calculated the period, which was 2. So how would I graph my function? I will find the point 2. Then the next step, you will divide that period into 4 pieces, 4 equal pieces. So I'll divide that 2 to 4, which will be half. So I'll have this to be half, then 1, then 3/2. So these are the four main quadrants for our function. Then I will just graph our known sine. So that is the sine. I will just graph it, but for these numbers instead of the known numbers, which were pi/2 and pi and 3pi/2. No, we'll just graph the same. We'll just sketch the same graph, but for these new parameters. So we'll just make it like this. Then I repeat it. Okay. What about this number? What should it be? Now I have taken that function. I've just grabbed this function, which is sine. A sine ends at 1 and -1. Okay? What if you multiply it by 2? That is a vertical expansion. So it will be instead of -1 to 1, it will be from -2 to 2. So these numbers will be -2 to 2. So that is the effect of that 2 multiplied. If you remember that we had learned, if you multiply a function by 2, you are making a vertical expansion. Okay. What about that negative sign? What is the effect of that negative? If you take a function and you multiply it by negative. Do you remember? Yes. What was the meaning of multiplying a function by a negative sign? It was a vertical reflection. That was a vertical reflection. What is meant by a vertical reflection? It means that you reflected about the x-axis. That is a vertical expansion. That is a vertical reflection. As you see here, the direction of my movement of my hand is vertical. Okay, so that is my reflection here. It is about the x-axis. So what should I do? Yes, it will be reflected like this. So that red function is just f of x. That is the sketch that I need in this case. Okay. So I've learned how to graph my function. Okay. Let's check another problem. For f of x is equal to sine squared 3x. And we need here to find the amplitude and the frequency and the period. Now remember, that each of the characteristics that I've taught you, the amplitude, frequency, and the period, were calculated in an expression which for the sine is power 1. Any change in the power changes all of these values. So whenever I give you an expression which is not in the standard form, that is the standard form, sine omega x plus b. That is the standard form of the sinusoid. It is sine power 1. But I have here sine squared. So what should I do? I should convert that by the rules of the trigonometric functions that I've learned. I need to convert it to a standard form. What is a standard form? A standard form of sine and cosine, which is sine power 1 or cosine power 1. How would I do that? I have 3 very important rules that we will keep in applying them all over our study. We'll apply them in differentiation, we'll apply them in series, we'll apply them in integration. In all our study, we'll just apply these 3 rules more than once. Okay? What are these 3 rules? These 3 rules which change the second order trigonometric to first order trigonometric, or second degree trigonometric to first degree trigonometric. How is that? We have cosine squared x, or let me make it cosine squared some angle. Cosine squared some angle is just half 1 plus cosine double that angle. And sine squared angle is just half 1 minus sine double that angle. Also another expression which is sine some angle times cosine the same angle. That will be half sine double the angle. Okay? Why are these expressions important? As you can see here, we have here the left hand side are second degree trigonometric functions. This is second degree, and this also we consider this as second degree, because we consider sine and cosine at the same level of difficulty, so we treat them as one. So you will have a first degree times a first degree, it will be second degree. So that also is the second degree expression. In this way, you make them all expressed as sine power 1 or cosine power 1, which is the first degree expression in trigonometry. Okay? So if I need to find the amplitude or frequency or period, we just need first to put it in a standard form, which is a sine power 1 or cosine power 1. How? By any of these rules. Which one should I use in this problem? The first or the second or the third? The second one. It is obvious, it is the second one. So I'll say here that this is simplified to be half 1 minus sine double the angle, which will be 2x. No, it will be 6x, which is double that angle. Okay? Now this is in the standard form, sine power 1. Now I can find all the characteristics that I need. What is the amplitude in this case? Half, yes. I will multiply this, distribute this to be half minus half sine 6x. So the amplitude will be the absolute of negative half, which is exactly half. As you notice, if someone didn't apply these rules, he will just take it as 1. No, this is a wrong answer. 1 is a wrong answer. Okay? So the amplitude in this case will be just half. What about the omega? Omega will be 6, yes. Omega will be 6. That's why 2 pi f will be 6. That's why f will be 6 over 2 pi, which is 3 over pi. And that's why the period will be pi over 3, yes, the reciprocal of the frequency. Let's check some other example. F of x is equal to sine squared 2x times cosine squared 2x. I will write again the rules so they can come before us. Okay, now for this problem, it is obvious that it is not in the standard form. We're having here a sine and sine squared, not cosine power, and sine and cosine power 2 also, and all multiplied and all multiplied to each other. What is the degree of this expression? What is the degree of this expression? Is it degree 2 or degree 4 or degree 1? This is considered as degree 4. Degree 4. I've just told you that we consider cosine and sine as the same degree or the same level of difficulty, so we treat them as 1. Okay? So that's why when you multiply a second degree sine times a second degree cosine, you will get an expression which you consider it as a 4th degree expression. Okay? Now we need to reduce the level, reduce the degree until it will be degree 1. So I can find the amplitude and the frequency. Okay? We need to reduce that degree. How would I do that? I just apply these 3 rules. Now, in which sequence should I apply these 3 rules? We apply them. We just start first by applying this rule. That is the best way. You may choose some other sequence which will do, but I'm telling you the sequence which will be more efficient. We start by applying this rule. We try to find, so for example, if I had sine squared 2x times cosine power 4 2x, I'll just apply this. To apply this, I will make it like this: 2 sine x cosine squared 2x times cosine power 4 2x, cosine squared 2x. Then I will treat this as sine 2x times cosine 2x all squared. All that to apply this rule in this. Okay? So that's why we apply that rule first. We try to find any common powers, make it with each other, then we apply this rule first. So in this problem we are having these, we are having the 2 powers are the same. That's why we just take them like this, all squared. Now let's apply the rule. Let's apply the rule. That will be half sine 2x. No, it will be double the angle. What is the angle? So it will be 4x. Now this is all squared, including the half. Why? Because many students just write it like this. Many students write it like this. No. The half is also squared. It is just inside the bracket. So that's why that will be 1/4 of sine squared 4x. Now, as you see here, we have managed to reduce the power from the 4th degree to a 2nd degree expression. That is a 2nd degree expression. Still, I haven't achieved my goal, which is to be power 1. But I'm approaching it. Okay, I'm getting closer. Instead of a 4th degree expression, now I have a 2nd degree expression, which is closer to degree 1. Now, how should I express it in the standard form? Can I put it in a 1st degree form? Yes. Which rule should I use? 1st, 2nd, 3rd. Which one? We use the 2nd rule. So that's why this will be 1 over 4 of 1 minus cosine 8x, which is double the angle. 8x, which is double the angle. So that's why that will be 1 over 8, 1 minus cosine double the angle. Now we have achieved a standard expression that we have cosine power 1. Now the expression is ready to find the amplitude and the frequency. Now we are ready to find the amplitude and frequency. What is the amplitude of this expression? It is 1 over 8. 1 over 8. What about the frequency? And what about the frequency? It will be, we have omega equal to pi f, which is 8. So that's why f will be 8 over 2 pi, which is 4 over pi. What about the period? It will be pi over 4. The period will be pi over 4. We have learned how to find the amplitude and the frequency of a single sinusoidal. But in this case, we are adding 2 sinusoidals, one cosine and another is sine. But pay attention that we have here the same frequency. So note here that we have the same frequency. We are having the same frequency. Okay? How would we find the amplitude and the frequency of such expression? Now this expression, we can make a trick to put it in a single sinusoidal form. How? If you remember, we have learned the rule which states that cosine A plus B is just equal to cosine A cosine B minus sine A sine B. Okay? So just compare these two expressions. It is something times a constant times cosine 3x plus constant times sine 3x. What if you consider this as a cosine? I will just say that it is an angle, some angle. I will just call it alpha. Okay, I'll just call it alpha. Also, let's consider this as the sine of some angle alpha, the same angle alpha. If that was the expression, if I had the expression f of x is equal to cosine alpha cosine 3x plus sine alpha sine 3x. This expression can be written as, if you compare these two, it is just in the same expression. So it will be cosine alpha minus 3x And we have known that the alpha, you can change the sign which is inside the cosine. It will be also can be written as 3x minus alpha. Okay? But there is a problem in my argument. Where is the problem? Where is the problem in my argument? How could you know that 3 is a cosine alpha? Is there a problem in saying that cosine alpha is equal to 3, or that 3 is a cosine of some angle alpha? Is there a problem in that statement? Yes, there is obviously a problem. What is that problem? We learned that sine and cosine. What are the values of sine and cosine? They are sine and cosine. Can they be greater than 1? Can sine and cosine be? No. Sine and cosine are always fractions. Or I say them, they are less than 1. They are always less than 1. These values are always less than 1. Okay? So that's why this is forbidden to say that cosine alpha is equal to 3. So there is a problem in this statement. We will just make a trick to make it true. How would I do that? Let's assume that I have a triangle which has 3 and 4 sides with 3 and 4. So the third side will be, it will be 5. That is just the square root of 3 squared plus 4 squared. Okay? So for this to be a cosine of an angle, let's say that this is angle alpha. To make it the cosine of something, we need to divide it by 5. And so for this number. But you have changed the problem. So for not changing the problem, you just multiply all the expression by 5. So I've just multiplied by 5 and divided by 5. What is that 5? It is just the square root of these two values, 3 squared and 4 squared. Why did I do that? To make these numbers as really a sine and cosine of some angle. To make them, I've just adjusted them to be valid as the sine and cosine of some angle. Okay? So that's why that expression, that same expression, we write it as 5 cosine 3x minus alpha. And what is the triangle of that alpha? The triangle of that alpha is just taking these values 3 and 4, 5 like this. This is the angle of alpha, so I know that it's cosine and it's sine. In this way, we can find the amplitude and the frequency and the period. So that's why the amplitude will just be 5. The frequency will be 2 pi. F is equal to 3. F is equal to 3 over 2 pi. And that's why the period will just be 2 pi over 3. So, as a general rule, you don't have to make all this argument every time you solve a problem like this. Whenever I have a summation or a linear combination of cosines and sines with the same frequency, with the same arguments, 3x and 3x. Okay? In this case, the amplitude will be the square root. Amplitude will be the square root of 1 squared a squared plus b squared. What are a, b? A, b are the coefficients of the cosine and sine we had. So for example, another example. Let's say that we have f of x is equal to sine pi x plus 3 cosine pi x. And I need to find the amplitude and the frequency and the period. What is the amplitude in this case? Now remember here I have just noticed that this is the same frequency inside the cosine and sine. Okay? So you can say that this can be expressed as the square root of 1 squared plus 3 squared times sine times cosine times the cosine of pi x minus alpha. What is the triangle of that alpha? Triangle of alpha will be that is the coefficient with the sine, which is 1. That is the coefficient with the cosine, which is 3. So that will be square root of 1 plus 9, which is root 10. Okay? So what will be the amplitude? The amplitude will be root 10. Amplitude will be root 10. What about the frequency? We have omega will be equal to 2 pi. F is just equal to pi. That's why F will be equal to pi over 2 pi, which is half. That's why the period will be equal to 2. Okay? The period will be equal to 2. As you have seen, we just put the coefficient. When you make the triangle of alpha, you put here the coefficient of cosine as the adjacent. You put coefficient of cosine at the adjacent, and you put the coefficient of sine as the opposite, at the opposite side of the triangle of alpha. Okay? Let's study another trigonometric function, which is tan x. Tan x. When you divide, we have learned that tan x is just sine x over cosine x. What if I say I need to find tan 0? Tan 0 is just sine 0 over cosine 0. We have learned that sine 0 is 0 and cosine 0 is 1. So that will be 0. So it starts as 0. Okay? What about if you need to find tan pi over 2? You need to find the tan pi over 2. It will be sine pi over 2 over cosine pi over 2. What is sine of pi over 2? Pi over 2, this is pi over 2, which is 0 and 1. So sine of pi over 2 is 1. Cosine of pi over 2 is 0. So what is 1 over 0? It is undefined, or it approaches to infinity. It approaches infinity. So that's why at pi over 2, we will have an asymptote. We'll have an asymptote for which the function grows like this, asymptoting that asymptote. So just grow rapidly until it goes to infinity. Okay? We'll have just another one in the other side. It will be like this, at minus pi over 2. Okay? Then it will repeat itself. It will just repeat itself. So that, what is the length of that interval? It is pi. The length of that interval is pi. It will just repeat itself each pi. Now we'll have another new asymptotes like this. And so on. It will just repeat itself like this every pi. That will be 3 pi over 2. No, that will be 3 pi over 2. That will be pi itself. That will be pi. And so on like this. Okay, so that is the graph of tan x. That is the graph of tan x. What is the period of tan x? What is the period? What is the interval for which the function repeats itself? It repeats itself every pi. This is obvious, so the period will be pi. The period will be pi. This is different from sine and cosine. The sine and cosine, sine x or cosine x with coefficient 1, the period was 2 pi when the coefficient is 1. And we have learned when you change the coefficient of x with some omega, we have learned how to find the period. But the standard sine and cosine are, so this is a function with period 2 pi and this is a function with period 2 pi, but when you divide them you will get a function with a period pi, not a function with a period 2 pi. Okay, what about the domain of that function? What about the domain of that function? How to know the domain? We look at the x-axis. We see if there is a curve in which values in the x-axis that has a curve. Are all the values accepted to be as an input to tan x? No. Why? There are some exceptions. So it is R except some values. What are these values? Yes, these values. We have learned here that there are some values for which tan is undefined or equal to infinity. Infinity is not a number. Infinity is not a number, so it is not considered as a part of the domain. When you have a function going to infinity, growing to infinity, we don't consider that point as a point in the domain. So that's why we exclude these values, which are plus or minus pi over 2 and plus or minus 3 pi over 2 and so on, which we can express them as r with the exception n pi over 2, but any n? No, n odd, which is 1 plus or minus n, or we can write it as n plus or minus 1, n plus or minus 2, plus or minus, no, not plus or minus 2. Plus or minus 2 is not one of the accepted values. Plus 1 of the minus 3, plus or minus 5, and so on, which is n odd. N, we just may write n odd. We may just write n odd. What about the range? Yes, it is R. We look at the y-axis to see if there is a curve. No, you have all the values are contained in the range. So we have the range to be R, all R. The range will be all R. What about the symmetry of that function? Is it even or odd or general? It is odd. It is obviously odd. As you can see here, this one, then you will have it as if we have reflected like this, then we another reflection like this, a reflection like this, then another reflection. When you make two reflections like this, the function is odd. Okay? And it's also obvious from this expression. We have learned that the sign is odd or even. The sign is odd. Divided by an even function, then you will get an odd function. If you divide an odd function by an even function, you will get an odd function. So that's why tan is an odd function. So that's why tan minus of some argument, it will be just minus the tan of that argument. You just take the minus out of the tan. Now, as you have seen, for tan x, what is the domain? The domain, we can say that domain x is not equal to n pi over 2 n odd. So we have some expressions for x, or for what is inside the tan. So if I told you, if I required the domain of this expression, all values are accepted, except the values for which what is inside the tan is equal to n pi over 2, n odd. So you just need to exclude these values from the domain. So that's why when I say 3x is not equal to 2 n pi over 2, this is just equivalent to, I divide by 3, it will just be n pi over 6 with n odd. And we can say that domain will be R except n pi over 6 n odd. If that condition is not written, then it is a wrong domain. If you put, for example, n equal to 2, n equal to 2, n pi over 3, this is an accepted value. So if n is even, it is accepted. For n even, it is accepted value inside the tan. Only odd values that are not accepted. What if I need to find the frequency and period of this function? Now remember, we have learned in sine and cosine to take that value to be 2 pi f, which will equal to 3. That was in sine and cosine. But in our case, it will be, we have learned the period of sine and cosine was 2 pi. But in this case, the period of tan is equal to pi. So that's why in finding the frequency and the period of tan, we just find pi f instead of 2 pi f. Okay? It is pi f instead of 2 pi f. So that's why in this case, f will be equal to 3 over pi. And the period will be, for this function, when you change what is inside the tan, it will be pi over 3. The reciprocal of the frequency. Okay? Now for this function, if I have f of x equal to x over tan power 4 x cubed plus x, and he needs me to determine if this function is the symmetry, or if it even or odd or general. If it is even or odd or general. Let's check it. We have here a numerator and denominator. That is an odd or even. X is odd function, so it is, give it a negative sign. Now, in the denominator expression, we have a composed expression. I will just write it like this. I'll just write it again as tan x power 3 plus x, but all power 4. I'll just write it like this. I'll just rewrite it like this. Why? Just to be, for the expression to be obvious for me, which function is inside the other. Which function is inside the other. Because we have learned that f of even, when the inside function is even, the resulting function will be even. Will be even whatever was f. And when I have f of odd, we'll get a as f. These are the two main rules in composing function, when you put a function inside the other function. Okay, for this expression, we have first that insider function. That function is odd or even. That function is odd. It is obviously odd. We have here an odd function plus an odd function, which is, when you add up two odd functions, we get an odd function. So now we have a tan with an insider function which is odd. So we have this case. The insider function is an odd. The resulting function will be as f. which means as the kind of tan. What is the kind of tan? Tan is an odd function. So that function as a whole will be odd. That function as a whole will be odd. It is just as that tan, because what is inside the tan is an odd function. Okay, now I've learned. Now I have this that situation. I have an odd function, all power 4. The insider function is odd, so it will be as the outsider function. What is the outsider function? It is power 4. Power 4 is an even or odd function? It is an even function. So it will be as power 4, which is an even function. So that expression as a whole will be even. That expression as a whole will be even, which might give it a positive sign. Negative divided by a positive will just be a negative. So the resulting function f of x will be f is odd. So f in this case will be odd. For f of x equals a tan omega x plus b. Now this function, when I have the function to be tan is not. What is the amplitude of tan? Let's look at the graph of tan. We have learned that the amplitude of a function is the maximum, the difference between the maximum and the minimum, then you divide it by 2. So what is the amplitude of that tan? What is the maximum and minimum value of tan? It is infinity. It just grows to infinity and lessens to negative infinity. So this function, when we have a function tan, it has no amplitude. We say that a tan function has no amplitude. What about the frequency and the period? We say that I've told you that to find the figure with omega will just be pi f instead of 2 pi f. For the tan, it will be pi f. Because a tan completes a whole period in a pi. It completes a whole period in a pi. So that's why, so that will be pi, and that will be all over p, or the period. Okay? So, for example, if I need to graph this function, find the frequency, then sketch. And it's giving me this function. F of x is equal to 3 tan 4 pi x. What about the amplitude of this function? Is it 3? No. Tan doesn't have an amplitude. Doesn't have an amplitude. Okay. What about the frequency? I just say that this number, it will be pi f, will be equal to 4 pi. That's why the frequency will be equal to 4. The frequency will be equal to 4. That's why the period will be equal to 1 over 4. Now, if you remember, when sketching sine and cosine, when I knew the period, if I had the period to be equal to 8, for example, for some sine, and I have found the period to be 8, and then I need to sketch it. We have learned that the first step is to divide that 8, or that period, into how many segments? 4 segments. Yes? So we divided it in 4 segments. 8, that will be 2, 4, 6, and so on. Okay? Then I graph my sine or my cosine as known. For the tan, we divide the period into 2 segments. Why? Because the tan, as you see here in the graph of tan, yes, here is the whole period. It is divided in two segments, one in the positive and one in the negative. Then we put the asymptotes as like this. Okay, so we'll just take that period that we have found. Okay, that period, then we'll divide it by 2. Divide that period by 2, we'll have 1 over 8 and minus 1 over 8. That's the whole period. That is our whole period, which will be 1 over 4. What would I make in these two bounds? I will just make two asymptotes. One asymptote like this, one asymptote like this. Then I make my graph like this. So this is how to graph a tan function. Then I repeat myself. And so on. Okay? That is how I find or make a sketch for a tan function. Now, look, if I have some periodic function. A periodic function is something like this. It is a function that repeats itself every some interval. Okay? It repeats itself every some interval. So this is our period P. It repeats itself every some period P. Okay? Now, if a function repeats itself every period P, does it repeat itself every 2P or not? Can I say that this function repeats itself every 2P? Yes. If I look at the function, I can consider this whole as a whole. This is 2P. That this whole 2P, does it repeat itself? Yes, it repeats itself. As you can see here, this is another repetition, and so on. So whenever I have a periodic function, the function will be also periodic for a positive integer of that period. It will be also periodic for a positive multiple of that, for an integer multiple of that period. So whenever it is periodic, it will be also periodic for 2P, it will be periodic for 3P, it will be periodic for 4P, and so on. All of these can be considered as a period for that function. But there is a more specified period, which is, we call it the fundamental period. What is the fundamental period? It is the minimum interval for which the function repeats itself. Okay? So any of these are periods, but we call the minimum interval for which the function repeats itself, we call it the fundamental period. Okay? We call it the fundamental period. Now, if I have a linear combination of two sinusoidal functions with different frequencies. For example, if I had this function 2 sine 2 pi x plus cosine pi over 2x. These are two functions with different frequencies and different periods. Let's get the period of that function and the period of that function. For one, let's make this to be 1, this to be 2. For 1, we'll have 2 pi f will equal to 2 pi. That's why f will be equal to 1. The period will be equal to 1. So P1 is equal to 1. For 2, we'll have that 2 pi f is equal to pi over 2. That's why the f will be equal to 1 over 4. That's why P2 is equal to 4. P2 is equal to 4. So we have here, in this case, the first one repeats itself every 1 unit, but the second function repeats itself every 4 units. What would you expect the sum of these two functions would repeat itself? What interval would it repeat itself? Every 1 or every 4? We have learned that if a function repeats itself every 1, Then it will repeat itself every 2 also, and it will repeat itself every 3. It will repeat itself. All of these are considered as periods of the same function. All of these are considered as periods of the same function. For the second function, it repeats itself every 4. Also, I can consider it to be a period to be 8. Also, I consider it to be 12. Also, I consider it to be 16. That function repeats itself every 4, or I consider the period to be 8, and so on. So what is the minimum interval for which the sum as a whole repeats itself? It is the least common multiple, which is that 4. The least common multiple, LCM. Okay? This repeats itself every 1. This repeats itself every 4. But as a whole, I just need to find when would that whole repeat itself. It is repeated at the LCM. You can just check it as if I have this function repeats itself every 1, but another function which repeats itself every 4, and so on. So when I add them, I need them to be repeated. So the fundamental period will repeat every 4, not every 1. Why? Because the second one doesn't repeat itself every 1. Okay? So how to know the fundamental period of a combination of two functions? We find the LCM of the two periods of these two functions. If there is no LCM between them, then the resulting function will not be periodic. For example, if I had sine 3 pi x plus 3 cosine 4x, and I need to find the fundamental period. I will just find P1 and P2. Okay? I will just take, and that will be P1, we'll find it to be 2/3, and we'll find P2 will be equal to pi over 2. Okay, so for P1, it repeats itself every 2/3, every 4/3, every 6/3. I just multiply it by 2, multiply it by 3, multiply it by 4, and so on. Okay? For P2, it starts with pi over 2, it repeats itself every 2 pi over 2, repeats itself 3 pi over 2, and so on. Would there be any LCM between these two periods? If there is any common period between these two? Never. Why? Because it is multiplied by pi. So whenever I multiply by an integer multiple, in this case, I will never approach one of these. Okay? So this case, this function is not periodic. It's not periodic. Why? Because there is no LCM between these two. No LCM between these two. So the function is non-periodic or not periodic. A last example in this case, if we have these two functions, f of x is equal to 2 sine pi over 2x plus tan pi over 3x. This is the first function. The second function, the first function, we'll find that 2 pi f is equal to pi over 2. That's why f will be equal to 1 over 4, and that's why p1 will be equal to 4. For the second function, we have 2 pi f equal to pi over 3, which is f will be equal to 1 over 6. That's why p2. Oh, yes, in this case, remember this is a tan, not a sine and cosine. So what is the fault that I have done in this step? In a tan, when you find the frequency, we just apply which rule? Is it 2 pi f equal to that number? No, we apply what? Pi f. We apply pi f instead of 2 pi f for tan. Okay? So that's why that will be 1 over 3. and that case will be 3. Okay? Now let's add up these two to find the LCM. To find the LCM, for 1, we have 4. It repeats itself every 4 or every 8 or every 12 or every 16 and so on. I just make integer multiples of that main frequency, which is 4, main period, which is 4. For the second one, we start with 3, 6, 9, 12 and so on. What is the LCM between these two? What is the least common multiple? What is the first number that is common between both functions? It is 12, yes. So the fundamental period is 12. I may ask for the fundamental frequency. What will be the fundamental frequency in this case? It will just be the reciprocal of the fundamental period, which is, it will be 1 over 12. Okay? So that's how we find the fundamental period of some given function.